Hey everybody, this is Clint Hajjar, and we are in ITL 518 with Professor Feeney. Um, my learning progression assignment is going to be, it's based on the 5PS2, which is grade 5 physical science. And this particular, this particular, I'm sorry. This particular assignment is going to be on motion and stability, forces and interactions. And the main idea behind this is to get students to actively engage and want to learn about gravity. And what we want to know, what is gravity, and how does gravity affect us on Earth? Um, And it's a really huge concept because we have the sun, we go around the sun, we have the moon goes around us, and the sun being as big as it is, the earth being as small as it is relative to the sun, um, what would happen if we were pulled into the sun? If the sun was any bigger and had more gravity, what would happen to earth? We might get pulled into the sun, nearer to the sun, and that would be devastating for life on Earth. So concepts like that are probably the more critical, or probably the more advanced part of this. But we want to have students understand what gravity is in general and its importance to us here on Earth, and why things that are smaller than Earth um, are attracted to the center of the Earth. So another major concept is the larger an object, the more gravitational pull it has. So we speak about asteroids and things like that coming crashing on down to Earth. Well, it's because they are smaller than Earth, and if they're not coming in fast enough, they would actually get caught in our orbit, and then potentially they would be attracted to the size of the Earth. It has its gravity pulling them down. But so the important thing here for our week 2 ITL 518 class, big concept for us here is getting students to engage and want to learn, and not boring them with lecture like I'm doing right now. We wouldn't talk about this, but rather what we would do. Okay, well, here, let's start with our, so this here is our 5PS2 motion stability, and the point of this is we want students to understand that Earth's gravity pulls things down to the Earth's spherical center. Our SEP is good. We want to be able to have students provide evidence and data, and be able to. This is let's see. Uh, our SEP ties in very closely with 5PS2. Our SEP and our ELA tie very closely together, because the SEP wants students to be able to support their argument with evidence and data, and or model their conclusion. And our ELA is RI 5.1, RI 5.9, and writing 5.1A through D. And 5.1 and R1, RI 5.1 and 5.9 Essentially, they want students to be able to retrieve a multitude of information based on a single subject and combine it to come up with, to learn, to come up with an idea that supports what they're learning, and to be able to quote the material they're referencing. And then the writing 5-1 is essentially it's for them to write, be able to write their opinions on topics. Um, our cross-cutting concept is cause and effect. So, what would happen if the Earth was half of the size that it is? Would the moon pull us towards it rather than us, pulling the moon towards us? What if the Earth was twice its size? Would the moon come crashing down on us? So our central question is, what is gravity? We want students to be able to critique peers' solutions by citing relevant evidence, as we just stated. That's our SEP. It's in our ELA. And then our, I'm sorry, I forget what it's called. Wrong one. Our DCI is going to be, basically explaining gravity's effect on Earth. The phenomenon is, why do asteroids come towards Earth and how do we stop them? So this is like a big deal right here. This might get students wound up, it might get them excited, because it is kind of a scary thought, and at the same time it causes intrigue and curiosity. How could the national government deflect them? But that's a topic for another day. But we need to learn what's going on before we get there, and this would probably provoke some good interest. As far as math connection goes, there isn't too much besides using our inequality signs. Um, we might get the rate of gravity at some point. Students won't need that for a long time. Our assessments, our worksheets can be digital, Word docs, and we'll use things like YouTube and stuff to conduct searches. We'll use the internet, etc. That'll be our technological connection. We already spoke of our ELA connection. Okay, and then the prior knowledge that we want students to have coming in here is, although this is a 5th grade physical science, our last time that we, according to the California state standards, the last time we saw physical science 2, was in grade 3. So in grade 3, we had 3 PS2, which was motion and stability. So it should have been 2 years ago. And students essentially should have learned a little bit about, if the forces are equal, nothing happens. If a force is greater than the force has force and direction, acting on something will push it or pull it. And hence, if there's more than one force acting on an object, the one with the greater amount of force will determine the direction of movement. So that would be kind of our prior knowledge. And getting students to ask about gravity forces in orbit, that would be great. Students will observe videos, conduct experiments, take field trips to learn. We want to not have so much lecture, but rather we want to be hands-on. We want to be digital. We want to be physical. We want to hear and see things that capture our attention, that make us feel an emotional attachment to the material. And with this gravity and Earth, it's quite easy because it's a big, we're talking about the Earth and asteroids and orbit, and a teacher can build up some good uh, engagement with this. Uh, a big question here that I thought of was the teacher could ask the students about the purpose of gravity and its effect on the seasons. So this is like this is pretty critical thinking here, but essentially gravity and the seasons tie in together because again, like we go around the sun. The sun is huge; it's a lot bigger than Earth. So with the size of the sun and the size of the Earth, we keep a certain distance away from each other. If the sun were to say double in size, or we were to shrink, and we would be closer, and our weather would be different. We might cease to exist. But also that distance that we keeps us in that orbit that we're on, and that orbit predicts our seasons. So our gravity keeps us in a certain orbit, and that orbit keeps our seasons the way they are, and our weather more or less um, what it is. So the bell rings. We got a bell ringer. Students don't know what to expect today. They walk in. This is on the board. Bell ringer. Why do tree leaves fall to the ground and not float up into the air? Draw a picture that demonstrates your knowledge. So, cool picture, just something fun. Drop a tree, maybe with some apples falling, leaves falling, etc. Something fun. It kind of builds that. It's related to what we're learning. Part two of our lesson would be to watch this video. I found this video on YouTube. It's by Vox, and it's really it's really interesting, and it drives home a message, and it gets I almost want to call it scary, but it's not. It's just it's about the Earth and asteroids, and it's totally elementary appropriate. I think it would be a great video to start the lesson rather than lecture. This would kind of just get students thinking, and yes, you will be able to get the link from the references sheet. And I accidentally started playing the video. Did not mean that. Part three of the lesson plan would be essentially so we've done the drawing, we have watched the video, and now we're gonna, rather than lecture again, we don't want to lecture too much. This is almost like a quick lecture. It's not even a lecture. We got four concepts that we're gonna address, and there they are. And students are gonna have, obviously we're dealing with differentiation here, so whatever method students can use to look up, learn, and model each of these concepts. Now this might not be a one-day thing. It seems like a lot. Again, I don't have experience teaching at all, so I don't know what something like this would take, how much time-wise. But it doesn't seem like it would be either all day, or it would have to be split up into multiple days in order to learn something like this. Here's a diagram I found on Pinterest. Again, it's in the references sheet, and this just kind of draws out the the relationship between the size of the sun and the size of the earth and the difference in the pull, the gravitational pull that they have on one another relative to their size, and the same goes for the moon. So this could be a good topic during this lesson. Um, this is a wonderful video. It describes multiple scenarios on the where the Earth is, the Sun is, planets, asteroids. The black spandex in this video represents space-time, essentially just the air. Um, so building something like this would be very nice, especially building it as a class, or making groups and having the students build their own galaxy, or not so much galaxy, but I forget what it's called. Planet system of orbital system. Maybe the big heavy ball could be the sun, and then marbles, golf balls, different other types of balls can represent items in orbit. Oh, so that, again, I meant to play the video. Okay, and objective of this assignment is to have students. So essentially, at the end of this assignment, possibly for assessment's sake, we would want students to possibly be able to answer these 5 questions. Maybe after a couple days of work, we want them to be able to critically think about gravity, Earth, the sun, and the relationship they all have with one another. And I really appreciate time. Thank you so much. This was Clint Hajjar, ITL 518, and see you guys next time. Thank you.